Hi and good day everyone. Welcome to waxaad channel where I share real project experiences for better skills that will lead to higher pay career. Today, I would like to share with you how to calculate NPSH and avoid pump cavitation. I believe you often heard the term NPSH in the pumping system and the pump damage due to cavitation in water industry. What is NPSH exactly? And what is the term cavitation all about? Which formula to calculate the NPSH? How to avoid the cavitation? You will learn all these if you follow this video till the end. Please subscribe and like my channel before we go further. There are a few technical terms that you need to understand first. NPSH is the abbreviation for net positive suction head. NPSH available or NPSHa is the net positive suction head available from the application at the pump suction side. This information shall be calculated based on the pump suction arrangement. NPSH required or NPSHr is the minimum suction head required at the pump suction flange. This information will normally be provided by the pump manufacturer. Cavitation is the creation and collapse of the air bubbles in a fluid where the bubbles quickly develop around the impeller's axis. When the bubbles pass from the middle of the impeller to the outer edges, the centrifugal force creates high pressure, causing these bubbles to quickly collapse or implode with great force. The forces generated by the implosion of those bubbles will cause huge vibration and pitching effect to the impeller. Ultimately, all this impact will cause major damages to the pump impeller, body and motor. In the pumping system, we try to avoid the cavitation by designing the pump suction piping arrangement in order to have enough NPSH available as compared with the NPSH required. This can be done by the formula NPSHa minus NPSHr greater or equal to 1. In this formula, the safety margin is 1 meter. NPSH available can be calculated using the following formula. NPSHa is equal to H atmospheric plus or minus Hs minus Hf minus Hm plus Hv minus Hvp, where H atmospheric is the absolute pressure on the surface of the liquid in the supply tank. Typically, atmospheric pressure but can be different for closed tanks. Hs is the static head between the surface of the liquid in the supply tank and the center line of the pump. It can be positive or negative. Hf is the friction losses in the suction piping. Hm is the minor losses in the pump suction piping. If you want to learn more on the Hf and Hm, please watch my other video, Pump Sizing and System Characteristic Calculations, to teach you how to determine the Hf and Hm. Hv is the velocity head at the pump suction port. However, the velocity head is often not included as it's normally quite small. Hvp is the absolute vapor pressure of the liquid at the pumping temperature. This vapor pressure must be subtracted in the end to make sure that the inlet pressure stays above the vapor pressure. Please note that, with an increase in temperature, vapor pressure also goes up. Let's take the below as an example. A suction sump has a minimum water level of 8 meter. The pump center line is 5 meter. The atmospheric pressure is 1 bar, which is equivalent to 10 meters water head. The friction losses is 0.6 meter. The minor losses is 0.3 meter. The vapor pressure at 30 degrees Celsius is 0.4 meter. Hence, the NPSHa is equal to 10 minus 5 minus 8 minus 0.6 minus 0.3 minus 0.4, which equal to 11.7 meter. To avoid cavitation, the NPSHa minus NPSHr must be greater than or equal to 1. Hence, the NPSHr is less than or equal to 10.7 meter. When you choose a pump from the pump manufacturer catalog, the NPSHr must be lower than 10.7 meter as shown. This will ensure the cavitation will not occur at all. That's all for today. Please support my channel by clicking the like and subscribe button. Thanks for watching.